Okay, so here is video 34. It's going to be partial fraction decomposition practice number 3. So here's the problem. 3x squared minus x plus 4 over x cubed plus 2x squared plus 6x. So the numerator is going to remain the same, and the bottom, you'll notice, has a greatest common factor of x. So we're going to pull that out. And then you're going to separate it into two factors. You're going to put a constant above the linear factor. So you have a over x, which you're going to add to the quadratic factor, which you're going to have a linear function over. So that's going to be bx plus c. Then you're going to multiply both sides by the denominator here. And so when you multiply the denominator by this first term, the x's are going to cancel, and you're going to get a times x squared plus 2x plus 6. And when you do that on this side, the x squared plus 2x plus 6 will cancel, and you'll get bx plus c times x, which is right here. And so first, we want to cancel a term out. So I notice that this last term here is going to be pretty easy to cancel because it's just multiplied by x. So we're going to let x equal 0 in order to do that. So we'll plug in x, and you get 0 minus 0 plus 4 equals a times 0 plus 0 plus 6 plus b times 0 plus c all times 0. So this last term here is going to cancel out. Notice how it's multiplied by 0. And then you're going to get 4 equals 6 times a, which tells us a equals 2/3. So now we have a, but we don't know what to do with the second term. So we're going to say that x equals 1, since we don't know how to cancel this term right here. And so that means that you get 3 minus 1 plus 4 equals 2/3 times 1 squared plus 2 times 1 plus 6 plus b times 1 plus c all times 1. That equals 6. 3 minus 1 plus 4 is 6, equals 2/3 times 9. 1 squared plus 2 plus 6 is 9, plus b plus c. 2/3 times 9 is 6, so 6 equals 6 plus b plus c. Subtract 6 from both sides, and you get 0 equals b plus c. Now subtract c from both sides, and you know that b equals negative c. Now we're going to try plugging in one more number in order to get our answer. And so the next easiest number to do that with is probably going to be negative 1. So we're going to let x equals negative 1 here. I've replaced our entire formula here and just put in 2/3 for a. So we're going to let x equal negative 1. So you plug that in, you get 3 times negative 1 squared minus a negative 1 plus 4 equals 2/3 times the negative 1 squared plus 2 times negative 1 plus 6 plus b times negative 1 plus c all times negative 1. And so that simplifies out to this. You have 3 times 1 plus 1, the signs cancel, and then plus 4 equals 2/3 times 1 minus 2 plus 6 plus b minus c. So 3 plus 1 plus 4 is 8 equals 2/3 times 1 minus 2 plus 6 is 5 plus b minus c. So now we want to get rid of that fraction, so we're going to take that equation here, and we're going to multiply it by 3. 8 times 3 is 24, so that's going to give you 24 equals 10 plus 3b minus 3c. Subtract 10 from both sides to get 14 equals 3b minus 3c. Now we know that b equals negative c, so we're going to put in a negative c for b, and that's going to give you 14 equals negative 3c minus 3c. So 14 equals negative 6c. Therefore, we know that c equals negative 7/3, which means b must equal positive 7/3. And so now we're going to plug that right into our equation, a over x, so 2/3 over x, then bx, so 7/3 x, minus plus c, so minus 7/3, all over x squared plus 2x plus 6. And then in order to get rid of all these fractions here in the numerators, we're going to multiply the whole thing by 3 over 3. So you have it on both sides here. And that's going to give you your final answer, which is 2 over 3x plus 7x minus 7 over 3 times x squared plus 2x plus 6. So that's the end of this partial fractions problem. Thank you for watching.